thank you to Hugh for making such a nice introduction of me. So there's no need for me to talk too much about myself at this point. But one thing I think for sure is that I'm just very passionate, and I love coming to, being an advocate. I travel to conferences and meeting people, understanding what your needs are, and then of course I'm advocating too. And these days I'm doing more about event streaming, things in that space. So that's why too, even today, let me kind of look for my clicker. Where's the clicker? Oh, right here, sorry. So I'll be talking about, really examining about, a bit deeper about terminology. Is it just semantics, right? Is it reactive or eventful, or are they actually the same? And so, so with that, let me start. So, so just to give you a background, when I joined IBM like 3 years, or actually I should say 2018, so before COVID, way before COVID. So I kind of got asked, there was at the time IBM had a partnership with Lightband. So that's how I started working with some Arca integration and then advocating for that. And that's how I met Hugh and Lightband, all of the great folks there. And there's just been such a great, friendship. And Reactive has always been dear to my heart. And it's just something about it, right? And just working with events, in that space. Although in Reactive, though, I'm noticing the word event has never been really like formally kind of put to the forefront somehow. So I kind of that's why I want to get into this topic. Now I'm working with event streaming, specifically Apache Pulsar, which I actually will have a talk this afternoon too. So with that, let me kind of, let's go back to some basic first. So what is reactive, right? I started looking into some basics. So reactive basically refers to distributed applications that meet, the kind of respect that four core principles, tenets of Reactive Manifesto. Responsiveness, elasticity, resiliency, and message-driven. So I don't need to explain too much. Everybody in here are already expert in that field. And but then the thing is too, it's interesting, as Hugh has mentioned too, initially the Reactive Manifesto came out, and that's what I was going by. But then I actually visited the site Reactive Manifesto and realized there's reactive principles, and that's been like added to that, which is kind of nice because I think it's now kind of bringing the manifesto, okay, again, manifesto is a bit more in my mind, right? Thinking more of an abstract kind of conceptual thing that we need to achieve. We need to have systems that are all those four like kind of principles, but how do we actually make it happen? So it gets into reactive principles in our design, which, is kind of nice, that saying that we need to stay responsive. However, I think that's where I feel that maybe the word responsive, if you go deeper, right, is beyond just the word itself. It can also mean, is it responsive for data that's at rest? Is it data in motion or in transit, or is it data in use, right? So there are different state of data too that we need to be worrying about responsiveness. So I think there's some kind of a deeper kind of what you call like, defining the word responsive in there. So I think with reactive systems too is basically dealing with, data in all states and being very responsive is my understanding. Anyway, then of course too, we need to accept uncertainty, and then with reactive way of doing things is asynchronous by nature. That's very much like decoupling the space and time, right? So so there can be things uncertain too. There could be network failures that we cannot assume network is always up, that type of stuff. And uncertainty, failure, and then assert the autonomy and tailor consistency of these things. They're still kind of high level, but I kind of like the fact that we really are decoupling the space and the time too. So you make, your style of programming or design, everything is very asynchronous in nature, and also handle dynamics. So over there too, as we know, is kind of like the diagram that we described the manifesto in there. So, okay, so that's reactive. Now, the thing is too, as I'm kind of working more with event streaming these days, and nobody talk about reactive, but I kind of try to draw some comparison between, these two camps of thoughts, right? So I call it like the alphabet soup of event computing. As we know these days, events, it's been kind of overloaded in the marketplace. The marketing team like to use that as a way of attracting attention, and certainly it has attracted a lot of attention too. And I go to speak at conferences. A lot of people may be curious, but the actual number of people actually using event-driven systems or using, asynchronous style of messaging are not that many for some reason. People are probably more curious than they are actually doing things. But anyway, so I kind of decided to look into all the terms, right? So there are like, essentially too, there's event, if you talk about events, I kind of not highlighting those in here, event sourcing, event-driven architecture, event processing, event streaming, event messaging, all of these. And essentially too for events, right? If I look into like the basic definition of an event, breaking it down like an atom too, it's basically an occurrence in space and also time. So think of like XYZ coordinate if you need to represent an event, right? And then, and it also has a time component to it. But the difference is that we don't like use one way of capturing the state changes. Essentially, we want to capture each, well, okay, so let's put it that way. Events basically are kind of finite too. So an event occurs, so you cannot change it. It's kind of immutable at that point. And then you are changing the state changes of that event as the data kind of travels through time. So the thing is too, at the core of it too, is that event messaging, event streaming, processing, all of these are dealing with data. And especially in today's world, this massive amount of data too can be, mostly too, are kind of events are data mostly like in motion or in use rather than at rest. Like, maybe reactive systems may be also working with data at rest because you need to be doing some sort of processing to data that's in a database or storage like that. But anyway, so that's just, at least in my mind, that's what I'm looking at it too. And also too, I've highlighted a couple of things too that I feel reactive systems are already kind of employing this event-driven kind of way of doing things. If it doesn't say it out loud, but it is actually using event-driven way of doing things, asynchronous. Perhaps like messaging can be using pubs up way of doing things, right? And doing message queuing depending on your usages, all of these things. But ultimately too, they are also talking about building data pipelines too that are highly, you can kind of stream data, like ongoing delivery of data really fast and everything like that. So that's reactive systems. And then of course too, it gets into serverless applications too. Serverless too, by nature too, is already using kind of an event-driven type of approach and can also be kind of applied to like reactive systems as well for serverless type of applications, or at least this is how it's being defined in the field. And then there's also like microservices too, as Hugh also brought up, right? These days we're all talking about microservices, and then the nature of microservices is so decoupled in nature and also like ideal for cloud native environment. Stateless is the way to go, but you can also support like stateful microservices as well. So all of these two are kind of, all these are really about event computing. Reactive is also so, but I think that if reactive definition is kind of higher level of abstraction. That is kind of not just about the event. Event may be kind of working more with, the mechanism of messaging, of streaming, processing, all of these, whereas reactive is probably like a higher level that you have all these goals you need to achieve. It's more abstracting out what is needed. Okay, so basically, too, if I kind of look through all of these, I find that, these are like just some of the goals, right? Where we're talking about apps that needs to be responsive, right? It can be, it also should be real time too, especially in event streaming cases. The real time is actually the goal of such too. Everything, not quite exactly real time, but it, strictly speaking, is basically near real time is what we're looking at. And then also too, they are both to event streaming in today's world, event messaging, all of these, and reactive. They also are, targeted in this cloud native environment. That is like so, kind of so important too, because in any kind of cloud native environment, you are being charged, by your usage. So you want to make sure that it is very efficient, is what it is. So. And also the aspect of recoverability from failure as well. So it's kind of the resiliency should also be built in. And then Also, too, very asynchronous, the messaging and processing part, there's no time that we can, allow it to be wasted, basically. And also, too, one aspect of using event streaming or event way of doing things are essentially, and with reactive systems, is that you can actually enable your data to be built as data pipelines to, your system. So you have data that flows through different systems, and then you can use different languages to implement your flow of your system, of your data through the system as well. So ultimately, too, I think it's what it is that event streaming, event computing, reactive systems are basically, we want to make a system that resemble how the human brains work. How do we interact with people? We don't, when we do things, right, we would be always doing things in a synchronous manner. Nobody is doing things like synchronous, right? If you're talking on the phone, nowadays you want to talk and both can be talking at the same time. All of these is a way of kind of resembling what real life should be like that. So that's how like event-driven approach, reactive systems are enabling us computers to work closer to how human beings think. But I guess unfortunately too, what I'm finding is because the way we've been taught, in school, when I first started school, we were being taught to program in synchronous style, blocking fashion. You have a request, you send the request to your processor, you have to wait for it, and then when it's done, then it sends back the response back to you. So I think that's how our minds have been trained, because that's probably the easier way to do when we first learn about computers, rather than thinking of things asynchronously. But I think that's the thing, is that we are trying to do systems that are more asynchronous these days. So yeah, so ultimately too, having systems that are more resembling real human interactions is that you're bringing it more like satisfactory in customer experience and more effective applications too. Okay, so then this is just what I'm kind of thinking in my mind, is that we have the event streaming, all of these event kind of things, and they kind of comes together essentially what we're trying to do is build better systems that resemble how the human beings do things. So that's how it is. Okay, so, but I like to, before I go to, just want to think of some challenges too, right now. As I'm finding, right, I mentioned about I go to talks and finding there are lots of people with lots of interests, but only, usually too, every conferences you have a few people that know the systems very well, and they come up with difficult questions. Those are really valid questions, but the majority of folks too are still kind of asking or learning about it. So I find that maybe because of this paradigm shift that's needed for us to learn. So perhaps too, we can think more about how can we make these systems to be more approachable by, more folks, if possible, right? And also too, because business too are not willing, they're usually impatient, and, with kind of anything that's more difficult, it takes more time to be educated in order to know how to do things. So that type of stuff. So can we kind of make the tooling a little better, maybe, and kind of make it easier for people to use? How can we design tooling to kind of serve people better, basically? And also, too, some of the other things I like to kind of think about is we want to kind of build in, guaranteeing security of message delivery. That's also very important. And also like easier debugging and observability kind of aspect too. And if we can actually do some like education on the grassroots level too, maybe to schools to start teaching kids to think, asynchronously. Maybe we can increase the adoption eventually. Like so it makes it more mainstream thinking rather than people coming out and learn things the old way. Then it's harder for you to switch to the new way. So that's that. Okay, so. Before I go to, just thought I'd kind of share with you, because I was at a couple of conferences, was kind of talking with some folks, and this one too, I think is a prime example as to why we need to definitely advocate for event-driven systems, event streaming, and reactive systems. I was actually talking to an architect of a major pharmaceutical company here in the Midwest, And he was describing to me this problem they are trying to solve. And I think, he was talking about some of the problems about, you don't want to be, waking up in the middle of the night to fix things. If you can do things more event-driven, it's actually easier for your life. But this particular example of the pharmaceutical company is that they are trying to do, they're selling medicine, right, to end users, or consumers. But the thing is, too, is that they are always going through, let's say, a CVS or a Walgreens kind of, middleman. So they've been only doing B2B type of business, but now they want to get into B2C, so directly to the consumer. So take, for example, if you get medicine for a diabetes patient, and the thing is, we want to maybe have devices of measuring the blood level sugar of the patient that's taking the medicine, and if it drops, right, you want to be able to have it notify somewhere that maybe, your pharmaceutical company, they want to keep track of all of these use cases. And so if there's a drop in your, blood sugar level, you want to notify, maybe you want to notify not only, well, the patient itself may not know himself or herself, but you want to notify maybe like their family, somebody close to their, or some legal guardian or something to notify them. So then they can take action on, kind of telling the patient, please take your medicine, you forgot about your medicine, something like that. So I think it's really exciting is that event-driven kind of approach can be applied to so many creative different ways that you can actually improve human life. And in this particular case with a diabetes patient or any kind of patient, they're taking medicine, you use this kind of system of being able to measure somebody's health and then being able to notify anybody that are taking care of this person. So then the life, maybe, not be ending too short. It's kind of like that. So anyway, so that's just an example of what I think this, is just an exciting field that can be applied to so many creative ways that can enhance our lives, and not only enhance, but really save lives too, in some cases. So I think then with that, let me kind of go into here. I just want to say thank you again. If you want to stay in touch with me, these are my LinkedIn and Twitter handle. And also I have a Discord server too, where I actually answer questions, but I actually have a Twitch channel too. But if you come to my talk, I'll share that with you. But otherwise too, I've been doing a lot of different things in my Twitch, so you're welcome to join me. So with that, thank you so much, and everybody please enjoy the conference. And thank you so much again to Lightband, to Hugh, to everyone giving me this opportunity to share with you. Thanks.